Okay, so non-ferrous metals and alloys is our Unit 4, Part 3. I know that this week, okay, we have like 4 parts. So I suggest you to do the Part 1 on Tuesday, and then Part 2 on Thursday, and then Part 3 on Saturday, and Part 4 on Sunday, okay? Anyway, so non-ferrous metals are all other elements, okay? So we study iron, and then we study steel. The rest of the metals are non-ferrous, okay, from your periodic table. Compounds included, okay? And so most of the students ask me to use a white background so they can print. I try not to put as many pictures as before. I usually like animations and things like that, videos, but then now we're taking them out separately, and okay, so I give you external resources. Traditionally we put it in here in the presentation, but then sometimes it's really bad because you can link out with the internet issue, all kinds of stuff. So we're trying to go back to make it still for the lecture purposes, so you can print and you don't feel bad when you print too many ink, yeah? And also we don't feel bad when the link doesn't work or the YouTube video doesn't work. So anyway, the separation is good. So all the videos and the website that I want you to go visit to expand your knowledge, you have to, okay? I'm going to be listed, okay, right after the videos, so you can watch them when you have time. I'm not going to babysit you anymore because you are not you're not a high school student anymore. You are over 18, okay? Over 18. Some of you already have family and a job, okay? So we would treat all of you as adults. So adults, you have to take responsibility. And taking responsibility is doing your job, okay? Your job as a student is to study. Your job is not working outside. Your job is not your family. When you're here in the university, your job is to study, okay? So make sure you do your part. School, we understand all the issues that we're having today, okay? And I definitely understand, because that's all the issue I also had before, okay? I still have now, but we still have to separate our family life, our work life, okay, with school, yeah? So let's try to do that. So make sure you're completing all your assignment. I don't want to say all of that in the lecture, okay? But then I'll have to remind you, because teachers, okay, your instructor, professors, your high school teachers, all teachers in your life, they're like a second parents to you, okay? We get that position automatically because you spend your time at school more than you spend at your home. So therefore, we have to take the duty of your parents to keep you, on the right track, okay? We won't get into more things, and that's up to you, okay? But your job, you have to do, okay? So if you're going so far on, I'm going to start talking, blah, 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 blah. So please get back on the track. And it's not a long time. It's only like 3.5 months to do this, okay? One semester and one semester, okay, they come and go real fast. So 4-year school it's just nothing, all right? 4 years, nothing. But then that 4 year will make a big difference in your life. So make sure you use your time, okay? Use your time wisely. Respect the time, because you will never get anything back. Especially time is one thing that you can't control. You just keep going. So please do your assignments. Study, study, study. Okay. A lot of the assignments are pretty fair, by the way. So make sure you do your job. Okay, let's go back to lecture. So non-ferrous metals are all metals, and then their alloys. And we're not looking at the ferrous metals and alloys, yeah? And it usually comprises of 3/4, okay? That's 3/4 of known elements. So here's a list. So these are non-ferrous metals that we use all the time. So we have copper, aluminum, titanium, zinc, manganese, and precious metals. Okay, so this four we use all the time. So the titanium precious metal, but this is really expensive. So we already use it. That's like your gold and your silver stuff. Okay, and here is your zinc. So it goes that way. So that's your copper. Okay, and this is your aluminum, and that's your titanium, your zinc here, your manganese here, and that's gold. Okay, so like the lectures in my time they give us only picture. They don't give us like this kind of writing stuff. And some professors give us mostly just words, but then some professor will give you like videos and then pictures. Alright, and you have to write your own notes like this. Okay, and if you can't produce from your big textbook or you forget to record the professor lecture, you're going to totally have an issue with your bedtime in the exam. So right now we're babysitting you. Okay, we're giving you everything. Oh, here's a note, here's a picture. Your job is to pick it up and study and put it in your head. And even though you don't want to do. So I'm like, what? Okay, totally shocked me. So please do something about it. Okay, not all students. Okay, some of the students, okay, about like 70-30, yeah. So if you're in the 30%, please collect yourself and start studying. Okay, so highest electrical conductivity. So we have three. Okay, first one is your silver, your copper, and then your gold. So what can they do? They can conduct electricity, meaning they can let the current flow, meaning their structure, okay, are very good for the electron to go through. Okay, electron is not going to go through. It's kind of like a domino. It just go like it will go into first, okay, nearest atom. So one, I can draw down a little one for you. So here is electric current coming and go into this first shell. Just because this guy taking that place, the original one from here, okay, is going to jump into the next atom like that. Okay, this okay current, which is we usually write it in. I hate drawing these things so hard. I want an interactive board. So anyway, so this current, okay, doesn't go through like that. Okay, even though if you look at from our system, we feel like if you touch the copper electric wire, you can feel it, and if you have water, then you're gonna get a shock right there. Okay, but it doesn't go like that. It actually goes like this. Okay, so this is an exaggerated diagram. So one electron. These are very very small. By the way, you can see them. So anyways, it's going like that. So if you touch the wire, you can feel that vibration. Yes. I'm going to erase this for you. So when you study, what I want you to do is to draw, okay? Draw the picture, because picture goes into the head faster than just reading some lines right there, okay? So try to draw the diagram to get the information into your head in an easy way, fastest way. So copper looks like that, okay? And we write Cu, okay, in short. I'll be writing this too for you, but later on we can write this way, yeah? So in fabrication, some of the traditional company will write that way. Some of the scientific company will write this way, okay? Okay, so one of the first industrial materials, copper, is a real good conductor. We already knew what's a real good conductor mean. So it transmits electricity, okay? So we use a copper, and we're going to transmit electricity into millions and millions and millions of homes, and we're doing it anyway today, yeah? So everywhere you go, you're seeing this thing, yeah? It's also go into the underground your And we also have underground cables, yeah, for electricity. So why do we have to do underground for the residential place? If we don't want people to tamper, right, the connections, yeah, because this connection is so important. If the criminals are smart, no, we feel okay because criminals are not smart, and smart people don't become criminal. So if the criminals are smart and they know how to, divert the electricity, you're gonna have an issue right there. Yeah, that's why we usually hide the source under the ground so you can dig, yeah, and mess around. Yeah. Anyways, it exists in nature in its metallic form, so you can get copper in a metallic form straight out of the ground. But we don't have it anymore. Okay, we don't have it because we've been living here for a long time. So since the ancient time, they've been digging out. Yeah. Okay, so process. How do you refine the naturally existing copper metallic form? We crush the rocks, and then we remove the chunks of the solid copper. So that's how we refine, okay, the natural copper found on the ground or in the ground. And they're more expensive because they're very pure, and they're even more expensive than the low carbon steel. So when you look at the steel, you have to pay about $500 per ton. Okay, but for copper, this little free sheet right there is like $80 to $100. So there's a big difference right here. Yeah. Pure copper. Pure copper is pretty good. Why? Because they're a really good conductor. They're corrosion resistant. They're very easy to fabricate, and they have reasonable strength. And then you can also solder and you can join it. Yeah, so pretty good. This is just showing you some example of various parts or products that we make out of copper and copper alloy. Okay, we're going to continue to study pure copper. Cu is the element structure, and we're dealing with the face center qubit. Okay, face center qubit, as you remember, all the cathode, right? Atoms are stuck on the surface. Okay, surface of the crystal cube, and we call it the face center cube. You don't have to remember all the chemical structure, by the way. All you have to just know it, so you won't be so ignorant. So copper ore is in the ground, and it usually contains, right now, about like 5% copper in it. And we use, again, refineries, the refining process. What are we doing? Oxygen and impurities, okay, they can get into the copper in that process, and we don't want that. So because of the oxygen and impurity content, okay, we have like a different types of copper. Okay, so you have your ore, you refine, in the process, oxygen and impurities can get into the copper. So therefore, depends on the content of the oxygen and impurities. We're going to put it into three different, okay, copper. The very first one is ETP. So we call it ETP because that's electrolytic top pitch copper. Oxygen free is there's no oxygen, not much oxygen in copper, so oxygen free copper. And the last one is a deoxidized copper. Okay, so three types. Again, depends on the oxygen and all the impurities. So make sure you study all of that, and that's going to be in your midterm. So midterm is unit 1 all the way to unit 4. Okay, so please study. ETP copper. So when you look at the ETP composition, you got like 99.9%, okay, copper, and you have like 0.04, so it's very low percent oxygen. So it can go ranges like 0.02 to 0.05%, okay, and it's cheap, so therefore we use it. We use it for wires, yeah, rods, and then plates, and then strips. Yeah. Oxygen free. This is your oxygen free. See, oxygen free copper protected with a little plastic cover wire. So 99.95% copper, and you have iron as impurity. So this type is produced in carbon monoxide and nitrogen atmosphere. So you need some cushion. So we use a cushion as a carbon monoxide and nitrogen medium. Yeah, and we're gonna make this copper with 99.95% and iron impurities. So what do we do in the process? We're going to get rid of Cu2O. Okay, that's the copper outside. So when you eliminate this, okay, that's going to increase the conductivity. But at the same time, iron will go in there. Okay, iron will go into the copper. So what are we doing? We don't like oxygen, we don't like impurities. We're trying to get rid of oxygen by trapping with copper. Okay, so we eliminate copper 2O. And when you compare to ETP copper, oxygen free is more expensive. Yeah, they come in different gauges. Deoxidized copper, it's about 99.99% copper, and we have like 0.009%, I forgot the percent right here, phosphorus. Yeah. So we will add sufficient phosphorus in the oxygen removal process. We have to get rid of oxygen. We don't want oxygen in copper. So how do we get rid of it? By adding phosphorus, that amount. Okay. So all the oxygen in the copper is going to be converted P2O5. Okay. So if you want to remove the oxygen, you have to carry the oxygen out of there with something. Okay. So when they form the compound, it's going to filter out. Yeah. So that's what we're doing in the chemical process. And so P2O5, we call it phosphorus pentoxide. That's just a chemical name. You don't have to remember it, okay? All you need to know is we're going to spike phosphorus to get rid of oxygen in the process, okay? And this deoxidized copper, here's an example of that. It has a very high electrical conductivity, okay? So see, copper deoxidized. Alloys. So when you look at the copper alloys, we group them into three. One is the brass, the bronze, and the beryllium copper, three of them, okay? And students, I don't know why, they usually cannot be able to understand brass and bronze are copper, okay? They think like brass is a separate metal. No, they are all copper, alloy, yeah? So here is a CD8, so that's a Copper Development Association. And again, the same as the AISI, they have their own codes. Okay, we're going to classify them. And what are we looking at? We're looking at the chemical composition. So if you see like this code, you have your raw copper and copper alloys. The pure coppers and high copper alloys having more than 96% copper, but not fitting into any alloy category, including beryllium copper, and that's your description. Okay, so here you're seeing the classification of copper and copper alloys. And this part for these two codes is for copper and copper alloy. Same thing, that's a raw copper. Okay. Not gonna ask you all of this, okay? But this three you have to know, yeah? Okay, brass. We'll get into brass, which is a type of copper alloy. There's a normal brass and yellow brass. Normal brass, yellow brass. So 60% copper, 40% zinc. Okay, we're gonna put zinc, 40% to 60% copper, and you get something called mains metal. And that is your regular brass. Now we're gonna put 70% copper with 30% zinc. You're gonna get yellow brass. Okay, only 10% off here from the original one. And then you have a different, because the variation in composition, different composition will give you different quality. So the variation in composition depends on what you're putting in, okay, to copper, because they're alloys anyway. So we studied these variation because we want all of that, the desired color, desired strength, ductility, machinability, and corrosion resistance, okay, different degree. That's the reason why we're playing with these numbers, okay, percentage. So if you add lead to the yellow brass, okay, which is this guy, you're going to add plus PB, you're going to get a lead brass. So lead brass is really good because they're stronger, so it improves the machinability. Red brass, composition 75% copper, 15% zinc. So they have more copper color than the yellow, okay? Meaning like it's not shiny yellow, it's more like a copper red kind of color. And the cast form will have this composition. So cast red brass form 85%. We're gonna bump it up a little bit, and we have 5% of reduced zinc, and then add 10. Okay, instead of 15 zinc, we split it 555 and add 10 and add lead. So we'll get the cast form. So alloy materials for brass, we can add these things. We can add aluminum, we can add tin, we can add nickel, and we can add arsenic. Okay, and these are the abbreviations. Try to remember. Okay, I try to teach you right now, so you're okay. Because some company use abbreviation, some company they use a full term. So here's a little red brass. You can see. Like I say, they're very similar, and the parts are. So the only way to differentiate them is to read the code, and use a standard charts. This is a product made, okay, from the red brass. So the artists and the sculptor, they use a material and then make these things. So tin bronze. Bronze, another type of copper alloy. Tin bronze, commonly known as a phosphorus bronze. And you're going to put copper with any alloy elements, but you can't put zinc, okay? And you're going to get bronze. If you put zinc, you're going to get brass. So copper tin alloy, we call it bronze. So tin bronze, what do we have? So we have copper, we have tin, we have 0.3% phosphorus. And this little guy comes from your refining process, okay? Like impurities things. Then we got tin bronze. So when you look at the properties, okay, quality, the high strength, they have wear resistance and they have good resistance. So I have my one student, he's pretty funny, and if I asked like what's the property in the exam question, he would list everything out. So that's one way to get full points, because since you list everything out, you can get wrong, If you didn't list like everything out, you wouldn't get like full points. He is pretty smart. Anyway, silicon bronze, copper plus 1 to 3% silicon KSI, and then 0.3% phosphorus. So that's how we make silicon bronze. So where do we use a silicon bronze? We use in shipping industry, so maritime industry, maritime applications. And I see majority of the students, they don't go into shipping industry. I don't know why the Mississippi students in Mississippi just want to stay local. I want you guys to reach out, okay, bigger companies, because you can do it, Try to expand your career choices. Don't just stick local, and stay, okay, where you feel comfortable. Explore, go outside. You guys, right? You have plenty of option to go around. And the shipping industry also really big, okay, and they definitely utilize industrial materials, when they build ships, so exciting. You know, even for going for a visit, you feel so good. Building airplane, rockets, oh my gosh. We have to find a way to take you guys. I wish this COVID thing to be over so we can go excursion, yeah, and look around the company. Okay, so high strength fastener. Okay, we use silicon bronze. So here is your phosphorus bronze, and this is your silicon bronze. A little bit different, yeah. Go by the code instead of looking the appearance. Aluminum, bronze, the composition copper, and we have 10% aluminum, yeah. And then you have phosphorus. So in the exam, students struggle because they can't remember all of this. So I suggest you better start writing it on a paper and get yourself organized. Okay. Since the exam has a limited time, you have to have all the answers on a sheet of paper. Okay, so organization is so important because you can go through all the lecture handout. Okay, you won't have enough time to flip in your computer the pages. So make sure you have all the. If I were you, I'm gonna just go ahead and organize all of my equations. Yeah, because they're pretty difficult to remember. Alright, hot and tough, that's their quality. So why? Because why is it hard and tough? Because they have really high tensile strength. Yeah. Aluminum, bronze. We're gonna add iron. So by adding iron to aluminum bronze, which is this guy, so you just plus iron, you're gonna get better strength and hardness, even harder. Yeah. So this means aluminum bronze mean your equation is going to be copper 10% aluminum plus 0.3% phosphorus plus iron. Yeah. So this is how aluminum bronze looks like, a little bit different. Beryllium copper is a real high strength copper alloy because the composition of it is we have copper and we have 0.6 to 2% beryllium alloy element in small amount, and then we're going to add spiked cobalt, yeah, so 0.2 to 2.5% special element cobalt in it. And heat treat, okay, the beryllium copper, that's Be for beryllium, copper, Cu for copper, alloy. We're going to heat treat it, okay? So by treating heat on it, we get tensile strength 212,000 KSI. So what is KSI? So I put a sticker here, okay? So you know the same thing as PSI, and we have also KSI, and that's for kilopound per square inch, okay? It's just a scale, okay? And it derived from the PSI on a normal scale for strength, yeah? But then it's a bigger, yeah? So that's the highest you can ever, okay, achieve in a commercial copper. Pretty good, yeah, the best. So beryllium copper, they're expensive, yeah. So copper, where do we use? We use in busbar, okay, busbars, electrical busbars, it looks like that, yeah. And they're pretty good conductor, like electrical or thermal conductor. So 50% of copper is used in United States, okay, just for conducting electricity. So in order for us to keep this conductivity high, we have to keep the impurities, oxygen low in copper, okay? So oxygen content got to be low in order to keep this conductivity high. So the products that we use are bus bars, wires, contacts, electrical contacts, very important, yeah. Switches, circuit boards, printed, transistor bases, okay. Our PC have a lot of transistors in it, okay, and they're very sophisticated, because we now have a smaller and smaller chips, yeah. Okay, let's go to the next one. Okay, um, So here, I'm just resting a little bit because my throat hurts. Okay, application of copper, you have your electrical or thermal conductor. So I already told you we use a 50%, okay? US for the electrical conductors, so this is why I'm reiterating here. Okay, so in order for us to keep this high conductivity, okay, we're gonna get rid of the oxygen. You can also add silver and cadmium, okay, to prevent annealing. So annealing is, remember, the heat treatment one then, so we don't want that. So property, when you take a look at it, copper can deform, okay, and copper can bend. And those are the desired qualities we want in copper, okay? We don't want it to be so brittle. And they're also high corrosion resistant, okay? I already told you about the products in a previous slide. I don't know why I copy it back again here. I'm thinking why. Okay, and then we have products for radiator cooling fins. And we have air conditioners, gas and heater liners, and gaskets. Okay, that's what we use. We also use in plumbing parts, okay, tubes, fitting, and gaskets. Because if you think about and take a real look at these products, because copper they can deform and bend, that's the reason why we can use them in plumbing parts, okay? Brass. Alright, so this is the next type of copper alloy. So we will put zinc into copper for brass, okay? But in order for us to differentiate brass from bronze, you have to think about what's in it with copper, yeah? So we're gonna wrap up. So when we study brass, we know brass strain increases, okay, by changing the amount of alloy zinc, okay, different strength, different amount of alloy zinc. So the best composition is 70% copper with 30% zinc, because that gives us the desired ductility and strength in brass. And we call them cartridge brass. And we use cartridge brass, right, for deep drawing because of this ductility. So like I say, if you have a higher ductility, you can draw better. Draw means like draw the material, you can stretch it. We're going to add manganese. You can also add iron, tin, and we're going to play with this tensile strength, okay? So here is your copper and here is your zinc. And we're going to spike either manganese, iron, or tin, okay? SN is for tin. Then add about 3% lead. Lead is Pb. So by doing that, we get like a better machinability, okay? Meaning like you can subject it to machine, okay? But at the same time, we reduce this draw, which is your ductility. So again, the same thing, your copper and then your zinc. You're gonna spike manganese, iron, or tin, and finally we're gonna add lead. Okay. Alright, so that's a review for your brass. Bronze. So we have tin, aluminum, and silicon. Yeah. Telling you the same thing. So, but here is a more we put them in a different group so you can understand like how they're different. So tin bronze, looking at the properties here closely instead of the composition in previous slides. So tin bronze, when you look at the tin bronze, okay, the quality is like their cold walkability, their strength, ductility, corrosion resistance, okay? And we use them because of these properties: electrical contacts, flexible hoses, pull line hardware, chemical hardware, and welding rods. Okay, the next type of bronze is aluminum bronze. So the qualities are hard, okay, high tensile strength, because they resist water and stress, fatigue, and they are corrosion resistant. Okay, so this is your aluminum bronze. Silicon bronze here, the same property as aluminum bronze, but then one property that silicon bronze can do more than aluminum is it can resist to the seawater, salt water, okay, corrosion. This one cannot. And cost, this guy is cheaper than tin bronze, okay? Okay, now we get into beryllium, the last one. So beryllium copper. So beryllium is Be, copper is Cu. So they have like a highest mechanical strength than all copper alloy. And beryllium amount, when it is low, you have a higher conductivity. So if you put a lot of beryllium, it isn't good for conductivity, okay? So quality, they're hard, but then they can't start, okay? Spark, which is your fire. So therefore, you can use it in chemical industry, okay? Where you don't want any kind of fire. They're corrosion and fatigue, that's stress resistant, okay? They are, but they're not cheap, they're expensive. And they're toxic. When you do casting, beryllium is toxic. Okay, so therefore you have to have safety training precautions before you cast beryllium copper. Okay, it can kill you. So definitely follow all safety precautions and procedures before casting beryllium copper. Okay, and some common people outside, without knowing it, they usually get into this issue. So what are we using? We're using electrical contact springs, chemical industry, gears, diaphragms, and valves. Okay. Okay, so that's it for part 3. I'm gonna do the part 4 probably tomorrow, yeah, because I'm struggling with typing and there are a lot of stuff that I have to do. Oh my gosh. And so we'll be posting part 4 probably Thursday, yeah. So you get the whole thing for the weekend to study. So again, don't forget the midterm is Unit 1 all the way to 4.